Hi everyone. Today in this video I am going to solve some examples on Leibniz theorem. So let's get started.
Find the nth derivative of x square into log x. So in this case, let us say this is equal to p and this log x is equal to u. So I will write here let u is equal to let u is equal to log x. Then what is its nth differentiation? Nth differentiation of log ax plus b is equal to, what is nth differentiation of log ax plus b? D raised to n divided by dx raised to n. This we have already proved. That is, the nth derivative of log ax plus b is equal to minus 1 raised to n minus 1 into n minus 1 factorial into a raised to n divided by a x plus b raised to n. So if you compare this log x with logarithm of ax plus b, the value of coefficient of x is 1 and this is nothing but the value of a, and here the term containing b is absent, so b is equal to 0. So here a is equal to 1 and b is equal to 0. A is equal to 1 and b is equal to 0. You have to substitute in this formula. If you substitute in this formula, un is equal to minus 1 raised to n minus 1 into n minus 1 factorial a raised to n. A value is 1, 1 raised to n divided by ax plus b is x, that is raised to n. So simply we can write it as un is equal to, so now this value is also equal to 1 because 1 raised to n is equal to 1. So we can write it as minus 1 raised to n minus 1 minus 1 raised to n minus 1 into n minus 1 factorial divided by x raised to n. And what is value of v? V is equal to x square. So by Leibniz theorem, by Leibniz theorem, d raised to n divided by dx raised to n bracket log x, that is u value, into x square, that is v value, is equal to, so by using formula first I have tried nc naught, then nth derivative is minus 1 raised to n minus 1 into n minus 1 factorial divided by x raised to n into the first term of v or v value, that is equal to x square, and then plus, next nc naught is over, you can write nc1, then minus 1 raised to n minus 2, minus 1 raised to n minus 2 into n minus 2 factorial divided by x raised to n minus 1 plus, sorry, into differentiation of this x square. Differentiation of this x square is equal to 2x plus next nc2 n minus, sorry, minus 1 raised to n minus 3 minus 1 raised to n minus 3 into n minus 3 factorial divided by x raised to n minus 2, and differentiation of this 2x is equal to 2. This is equal to, now what is the value of this nc naught? What is the value of nc naught? Nc naught value is equal to 1. This value is equal to 1, so I will not write. Then the remaining terms are, that is x square into, or simply transpose this x square in denominator, so minus 1 raised to n minus 1 into n minus 1 factorial divided by x raised to n minus 2 you will get, plus, now what is the value of this nc1? Nc1 value is equal to n, and then minus 1 raised to n minus 2 n minus 2 factorial into 2. Transpose this x in denominator, again you will get x raised to n minus 2 only. Okay, plus, now what is the value of this nc2? Nc2 value is equal to n into n minus 1 divided by 2 factorial minus 1 raised to n minus 3 into n minus 3 factorial into 2 divided by x raised to n minus 2. Now this 2 factorial and 2 factorial get cancelled. This 2 factorial is equal to 2 and this 2 get cancels, and you can take x raised 1 divided by x raised to n minus 2 outside, or minus 1 raised to n minus 1 also outside, and then what I done the remaining terms, or you can write as it is. So this is the required solution. Next example, that is, if y is equal to, if y is equal to x raised to n into log x, comma, prove that yn plus 1 is equal to n factorial divided by x. I will write here, let y is equal to x raised to n into log x. So now what is differentiation of y1? Differentiation of y is equal to y1 is equal to, now by using product rule, first term x raised to n as it is, differentiation of log x is equal to 1 divided by x, and then next term log x as it is, plus second term log x as it is. What is differentiation of this x raised to n? That is n into x raised to n minus 1. Now If you take LCM here, we can write it as x raised to n. LCM is x, or better directly I will write multiplying both the sides by x. If you multiplying both the sides by x, left hand side you will get xy1 is equal to right hand side. If you multiplying with this x and this x get cancels, so we are left with only x raised to n, and then multiplying here with x, so that you will get x into x raised to n minus 1 into n into log x. I have written at last. So this is xy1 is equal to x raised to n plus, here power of x is equal to 1 plus 1 and this minus 1 get cancels, again you will get x raised to n only, and then n as it is, that is n into x raised to n log x. Now you have to differentiate, or better I will write xy1 is equal to x raised to n plus n. Now the remaining term, what are the remaining term? This remaining term is x raised to n into log x, and x raised to n into log x, its value is equal to y, because x raised to n into log x is equal to y. So here I will write it y. Next, differentiate n times. Differentiate n times by Leibniz rule. Or Leibniz theorem. Okay, so first here I will write the nth nc naught value, that is nc naught. Then what is the nth differentiation of this y1? Because this is v term, this is u term, and this x is nothing but v term. So what is nth derivative of y1? Nth derivative of y1 is equal to yn plus 1 into v value is equal to x plus. Next, nc naught is over, here we can write nc1. Next, yn plus 1, 1 minus means we can write yn in the decreasing order. And what is differentiation of this x? Differentiation of x is equal to 1, and this is equal to, what is the nth differentiation of x raised to n? If y is equal to x raised to n, y1 is equal to n into x raised to, I will write like this, y1 is equal to n into x raised to n minus 1. Next, y2 is equal to n minus 1 into x raised to n minus 2. y3 is equal to n minus 1, n minus 2, and this is x raised to n minus 3. So this is, therefore, so on yn is equal to n minus 1, n minus 2, so on up to. Now you can see the power of x. Here the power of x is n, here the power of x is n minus 1, here the power of x is n minus 2, n minus 3, so that x raised to n minus 4, then n minus 5, n minus 6 goes on decreasing. At last somewhere you will get 3, and then 2, and then this 1. Similarly, this n minus 1, n minus 2, similarly it ends with 1. So this is 1 into x raised to 0 at last you will get. And this one you can write it as simply n factorial. So the nth derivative of this x raised to n is equal to n factorial. Then plus n into what is the nth derivative of this y? The nth derivative of y is equal to yn. Now n c naught value is equal to 1, so I will leave. The remaining terms are y n plus 1 into x plus what is nc1 value? Nc1 value is n. The remaining term is yn is equal to n factorial plus n into yn. Both the sides, this nyn get cancelled. So we are left with yn plus 1 into x is equal to n factorial. Transpose this x to the right hand side. Yn plus 1 is equal to n factorial divided by x. So this is the required nth derivative of x raised to n into log x. Next example, if y is equal to a into cos log x, a into cos into bracket log x plus b into sin log x, then show that x square yn plus 2 plus bracket 2n plus 1 y x into yn plus 1 plus n square plus 1 yn is equal to 0. So here I will write this is x into yn plus 1. So this is the example. So to prove this, let us see here. Here the highest term is yn plus 2. Yn plus 2 is obtained. So first given is y value. If you differentiate one time, you will get y1. If you differentiate again, you will get y2. And after that, if you differentiate n times, then only you will get yn plus 2. So we need to find the value for first y1 and then second y2, or you have to differentiate first 2 times. You have to differentiate 2 times and then you can differentiate n times. So this is the step. So first I will write, let y is equal to a cos into bracket log x plus b sin into bracket log x, and say this is equation number 1. If you differentiate with respect to x, what we get here? Left hand side you will get y1. Then this a is constant. What is differentiation of this cosine term? Differentiation of cosine term is minus sine and then log x as it is. And then differentiation of this log x is equal to 1 by x plus, next this b as it is. Differentiation of this sine term is equal to cos term, that is cos into bracket log x, and differentiation of this log x is equal to 1 by x. Now here you can take this 1 by x and this 1 by x common, and after taking 1 by x common, if we transpose to the left hand side becomes xy1 is equal to minus a sine log x plus b cos log x. Just you have to take this 1 by x common and transpose to the left hand side. So I will write, if you want, this is 1 by x is common, write down the remaining terms in the bracket and then transpose this x to the left hand side, you will get xy1. Next, differentiate again, because we have to differentiate two times. Differentiate again with respect to x. If we differentiate this xy1 by using product rule, first x as it is, or I will write here differentiate again, so that you will come to know. Differentiate again. What we get by using product rule? First x as it is. What is differentiation of y1? Differentiation of y1 is y2 plus y1 as it is, and differentiation of x is 1 is equal to. So left hand side we have differentiated by using product rule. Now in RHS, this minus a is constant. Minus a is constant. I will write as it is. What is the differentiation of this sine x? Differentiation of sine term is equal to cos term, and then log x as it is. That is, differentiation of sine log x is cos log x. And then what is differentiation of this log x? Differentiation of log x is equal to 1 by x plus, here b is constant. Next, b term is constant. What is differentiation of this cosine term? Differentiation of cosine term is equal to minus sine term. So I will remove this plus sign and I will write here minus sine function, that is minus sine log x, and then differentiation of this log x is equal to 1 by x. Again you can take this 1 by x and this 1 by x common, so that what you will get 1 by x into bracket, write down the remaining term. This 1 by x transpose to the left hand side, so we get that is x square into y2 plus x into y1 is equal to, from the remaining terms, this is the remaining term minus a cos log x, and this is minus b sin log x. From these two remaining terms you can take minus outside, and if you take minus outside we are left with a cos log x, a cos log x plus b sin log x. Then x square y2 plus x y1 is equal to minus into. So this is nothing but equation number 1, because this value is equal to y. Y value is equal to a cos log x into b sin log x. So this is equal to minus y. I will write here, since from equation number 1. So now we got the highest differentiation term, that is equal to y2. Now if we differentiate n times we will get the required solution. So now you can write differentiate n times. Differentiate n times by Leibniz theorem. Okay. Now first term is x square into y2. This x square into y2 you have to differentiate. So in this case y2 value is nothing but u and this x square is nothing but v. So first we have to find the nth derivative of y2. So for that what I will write, first n c naught. What is nth differentiation of this y2? Nth differentiation of this y2 is equal to y n plus 2. And then write down v term, that is v term is equal to x square. Now here only we can write plus. Nc naught is over. Next we can write here nc1. Y n plus 2 is over. In decreasing order you can write y n plus 1 into what is differentiation of this x square. Differentiation of x square is equal to 2x. Second term is over. Next nc1 is over. Next we can write nc2. Next yn plus 1 is over. In the decreasing order you can write it as yn. Next 2x, its differentiation is equal to 2, and next differentiation of 2 is equal to 0. So this is the differentiation of nth derivative of the first term only, that is x square into y2, its differentiation. Okay, which is over. Now we have to differentiate this x into y1 by using Leibniz rule. For that I will write plus. Again starts with nc naught. What is differentiation of this y1? Differentiation of nth derivative of y1 is yn plus 1 and v term, that is x as it is. Now nc naught is over. Next term you can write nc1. In the decreasing order yn plus 1, the next term you can write it as yn only. And what is the differentiation of x? Differentiation of x is 1. So I can leave this. So this is the nth derivative of second term is equal to minus right hand side. What is differentiation? Nth derivative of y. Nth derivative of y is equal to yn. Nth derivative of y is equal to yn. Now write down the values. So to write the values, what is the value of nc naught? Nc naught value is equal to 1. I will leave. Now write down the remaining terms. Remaining terms are x square into y n plus 2 plus. What is the value of nc1? Nc1 value is n and the remaining terms are 2x. So I will write here 2nx y n plus 1. What is the value of nc2? nc2 value is n minus 1 divided by 2 factorial yn into 2. This 2 factorial and this 2 get cancelled. So this is first bracket. Similarly in the second bracket plus. What is the value of nc naught? Nc naught value is 1. I will leave that term. The remaining terms are, this is x into yn plus 1. That is x y n plus 1 plus. What is the value of nc1? nc1 value is n. The remaining term is yn is equal to minus yn. Now here collect the terms containing n plus 2. The term containing n plus 2 is only one term, that is x square y n plus 2. So I will write here x square y n plus 2. Okay, now collect the term containing yn plus 1. The term containing yn plus 1 are 2nx yn plus 1 and this is x y n plus 1. From this you can take this yn plus 1 common. If you take yn plus 1 common, then what are the remaining terms? Here we are left with 2nx plus x. Again you can take this x also common. So I will write here simply, you can take, in spite of taking yn plus 1, you can take x y n plus 1 common, plus. Now collect the terms containing yn. The remaining terms are yn are n into n minus 1. Yn means if you take yn outside, here we are left with n into n is n square, and this n into minus 1 is minus n. Similarly, here we are left with, that is n yn means you can take plus n. Yn is common. Transpose this minus yn to the left hand side, you will get plus yn. And if you take this yn common, here we are left with plus 1 is equal to, right hand side you will get 0. This is equal to x square into yn plus 2 plus 2n plus 1 bracket complete x into yn plus 1. Here this minus n and plus n get cancels. So we are left with n square plus 1 bracket complete yn is equal to 0, which is the required proof.